So welcome everybody. My name is Sanvy. I'll be running you through basically KSQL, which is stream processing using Confluent Cloud. The intention originally was to use APIs that sit on top of KSQL to show you guys how to do stream processing, but we kind of decided that effectively the best way to do it was to show you the publish subscribe way to do it. If you were interested in using the REST APIs that sit on top of this, basically here's the URL. We'll send this out at the end of the session as well. But with publish and subscribe, you get real time. Effectively, the minute something changes, the change is reflected downstream in the database. I will be popping in and out between chat and between the presentation in case you guys have got questions. So feel free to type questions in here as you see fit. Meanwhile, I'm just going to start with the session. I'd encourage you to kind of follow along, but not actually do the workshop, because it's better that you understand rather than just try and do the workshop without understanding it. This is going to be recorded, which means you can go and watch this and play and pause at your own pace, and effectively run the workshop yourself as I'm doing here. But you can stop me, unlike the real-time version of me right now. So let's start. Effectively, what's going to happen is you're going to have to create a Confluent Cloud account. You'll have to sign up. You'll have $400 worth of credit when you sign up, so don't worry about it. Like, this is all covered within that $400. Basically, create an email and password, and you sign in. And one of the first things that you'll have to do is actually create an environment. So this is the login, the post login screen. Basically, you'll go and create an environment, which is here. Add cloud environment. You can call it whatever you want. Typically, we say call it KSQL workshop or something of that nature. I've already created it. I want to take you through the way that you set up all the different components. Keep in mind, when you're actually doing this real time, when you provision something like a piece of infrastructure, it takes a couple of seconds to come up. So that's why I've pre-built everything here. So basically, what we'll do is we'll start with creation of the Confluent Cloud cluster, and then we'll go from there. Just to make sure everybody's keeping up so far. I realize looking at the screen is really annoying, but if you got questions, just type in here. I'll be answering as we go through. So the first thing you do is create an environment, which we've done. We've created an environment called Apidays for Hong Kong. And then the next thing you do is you've actually got to go and add a cluster, pick a basic cluster, and then you click begin configuration. You pick whatever cloud provider you want, and then you pick continue, and then you pick launch cluster. I've already done this, so I've actually created a cluster in AWS inside Oregon. Basically, the cheapest possible cluster that I could find, basic cluster, and I've set it up. It takes a few seconds to provision. Once you click launch, it'll get going. The next step, after you've created the cluster, you can follow the step-by-step guide here, is basically create something called a KSQLDB application. Inside of the cluster, you go into here. You can say add KSQLDB cluster. Remember all the time that your KSQLDB will require global access. We can talk about what this does afterwards, but basically this means global access to your cluster. You select continue. You name it. So in this instance, we'll call it KSQLDB API HK. Your cluster size should typically have 4 CSUs. A CSU is what's called a Confluent streaming unit. It's basically a hardware equivalent, like the amount of RAM and stuff allocated to it. Typically, you can just leave default, but if you're interested, you can have a look at advanced. You basically launch cluster, But word of warning, keep an eye on this. As soon as you finish this exercise, you want to delete that cluster, because otherwise you'll be stung for costs. So again, we've already created the KSQLDB application. It's up, it's running, it's got allowed queries, and there's a whole bunch of persistent queries running. So what we've actually done is follow the instructions from here through to here. And now we actually need to create topics. So most people will ask what a topic is in Confluent, in Kafka. A topic is analogous to a database table. So basically, a topic hosts data. You can think of it as raw data. In this instance, we're going to be creating two topics, one for users, one for stock prices. So users will have things like, first name, last name, born, date of birth, gender, that sort of stuff. And the second topic that we'll create is stocks. It's basically users buying stock. This whole exercise that we're doing is about joining two streams, real-time streams, the streams being users registering inside of my application or having registered, people purchasing stock inside of my application, joining those two streams of data, enriching it, and then doing things like fraud detection, sending that to a monitoring solution, and a whole bunch of other stuff. This is actually quite similar to some real use cases that our customers use, which is why we use this in a workshop. This is very similar to like Customer 360, fraud detection, banking, and FinSec use cases. I'll just pause and see if there are any questions. No questions. Feel free to ask questions if you have any. So let's go and create the topics. I've already pre-done these, but I'll take you through it very quickly. So to create a topic, you basically go in here and you say add topic. We've already got a users topic. Let's call it users topic 2. In this exercise, the number of partitions is actually 1. I won't get too much into partitions. It's basically how the data is stored. Like you can store the data all in one partition or in many partitions. In this instance, the requirement is that you create 1. You can have a look at the advanced settings here. You don't really need to play with any of these settings. Basically click save and create. You actually need to create 2. The 2 topics, stocks topic, and you can see 1 partition for each. So users and stocks. The next step is to create an API key pair. Basically, this allows you to connect to Confluent Cloud or to Kafka to do things like insert data, read data. We're actually going to create what's called a data generation source for both users and stock. What will happen is it's going to simulate insertion of those data for both users and topics into Confluent Cloud. To enable this, the connectors will need an API key. So typically what we do is go to here, API keys, and let's say add key. Key needs to have global access. You click next. What will happen is the API key will be downloaded onto your computer. You'll need to save that because you'll need that key to basically allow data generation to connect to your machine. It'll download to your machine and then off you can go. So again, ensure that you save that because that's quite important. Now let's go to the next bit, which is basically creation of connectors. Connectors are going to be what's going to be inserting the data real time into Confluent Cloud. Again, it's going to be simulating users buying stock and users registering. So 2 different streams into Confluent Cloud. I'll take a pause again and see if there's any questions. I see Jeffrey's here. Jeffrey's one of us. Jeffrey can say hello. There's a whole bunch of other people that have joined. So welcome to the new people. Just to catch you up, basically you can click on the link in the chat. That will take you to the guide that I'm running through at the moment. I'm going to try and take it nice and slow, but try and get through as much as possible. If you have questions, theoretical or otherwise, just type in the chat. I'm happy to take questions as we go along. Okay, so now what we got to do is actually set up the connectors, which are going to create the data inside of Confluent Cloud. So let's go into connectors. The connectors you want to search for are basically data gen connectors. Let's actually just go and see all connectors, and I'll show you. So I'll bring down advanced configurations. Let's just go back to the instructions for a second. Effectively, what we're doing here, we're simulating data based on a user's click stream, a user's purchase stream, and a user's registration stream. So in the first instance, we're actually going to use this connector to simulate users signing up to our application. So in this instance, the data we want to produce is users. We want to create in JSON format, basically JSON output decimal format. Just leave that as the default. The max interval between messages should always be 1,000. You can click continue, and what will happen is it will ask you for a topic to drop it into. Now, I can click users topic, but I've already got a connector running and generating this data. As you can see, there's data being generated, and then you basically go add new topic. If you wanted to create it into a new topic, but we won't do that. Typically what would happen is, I'm not going to follow through with this because I've already got it running. You basically go continue, global access, and then off you go. In the event that you haven't created an API key, you can generate a new one, but you can always put the credentials of what we created before into here. Let's go back. What will happen is you'll have to repeat the process again with stocks. So this is step 3 completed. What we need to do is create the same step with stocks. So in this instance, let's go back to the connector. We're doing stock trades. We're doing JSON. This is the output, again, 1,000, and then we click continue. What will happen is same process, the data will be generated, and basically data will start coming into Confluent Cloud. Now, let me show you what that looks like before we go on, because that's the most important bit. So right now, I've got 2 topics. Let's start with the users topic. What you're seeing here is a real-time simulation of users signing up into my application. So this is the time that they register. This is the user ID. This is the region ID, like could be US or whatever. And this is, their gender. As users sign up, the clickstream, the data is going all into Confluent Cloud. The schema, which is effectively it's the equivalent of constraints on the database table. We haven't created a schema, but you can enforce a schema if you wanted to. And again, the configuration. One partition, the name of this is users topic, and data is coming into this real time as people register. Now, similarly, with stocks, we've got purchases of stock real time or selling of stock real time with the data that's coming across it. So this is the user selling whatever stock. This is the stock ticker. This is how much they're selling. This is the price as which they're buying or selling, and this is the buy or sell action. So you've got 2 different activities there, 2 different users, 2 different stocks. One is buying, one is selling, etc. So what we've actually got is 2 streams of data coming into Confluent Cloud, and I'll show you what that looks like. So users signing up, you'll have to forgive my JavaScript for a second, it's misbehaving, it seems. users signing up, users purchasing stock, both of this going into a topic. And again, a topic in Kafka and Confluent Cloud is analogous to a database table. It's just a space where data is set. And we're about to do a couple of things to this data. We're going to join them. We're going to enrich them. We're going to analyze them. And what you're looking at here is the end-to-end data flow. So the birth of the data, not really the depth of the data, but where the data goes to rest, and the analytics that we do in the middle. So just so we're clear, does everybody follow what we're doing so far? We've got 2 bits of data, people registering, people buying and selling stock, and then we're going to start some stream processing with this. So let me just scroll down to where we're going to be next. So we've had a look at the messages, we've seen the data. What we're actually going to do is create a whole bunch of streams and have a look at it. Any questions so far? No? Okay. Just to be sure that you guys can hear me, can somebody type yes in chat? Awesome, thank you. Okay, so now that we've got the data flowing inside of Confluent Cloud, we've actually got 2 streams of data. We're actually going to start manipulating that data and use kind of database, database terminology, but it's not a database quality, if you like. So in Confluent Cloud, a stream is actually a stream of data as it flows, right? So what we're going to do is we're going to create a stock stream from the topic, which is effectively based off the analogy of the database table, and it's going to be streaming data. So inside of Confluent Cloud, the way you do this, you go into KSQLDB, you click on the KSQLDB cluster. Inside of the editor, you would basically copy and paste this. And click Run Query. Now, keep in mind, I pre-built all of this stuff yesterday. The reason I pre-built it is because it takes time, and we don't have a lot of time today. So I pre-built all the streams and all the ancillaries, but what I'll do is I'll show you what that looks like. So we've created a stream called Stock Stream. Let's go into the streams and have a look. And you can have a look at the stream real time if you wanted to, right? So as you can see, what we've actually done here is created a stream of data that is pushed out real time of people buying and selling stock, right? So that's basically built on that topic that we created before. Now, let me tie this back to the API kind of world. If I wanted to query this, KSQLDB has a REST endpoint that I could query at any time. So if you have a look here, you can see KSQL select star from page views, make changes. Let's go back to my cluster. You see this? This is the UI. Effectively, this is the same thing. But what I'm doing here, this is a HTTP post request. I'm going to get data back as I request it. My value proposition to you is in real time in Confluent Cloud, if you actually got what's called a subscriber to this stream, you don't have to push the HTTP post request. The data comes to you as it hits the stream immediately. And so there's a series of benefits and trade-offs. Like most of our customers tend to use publish subscribe, but we do have customers that use the REST endpoint. And that's kind of like the value proposition of today, to show you like within KSQLDB and within stream processing, there's many different tools available, one of which is the API world, but there's also the real-time world as well. You can do, let me just show you a response to the stream. As you can see here, obviously 200 okay. I'm saying that the request was fine. but this is what you're after. This is the data, the payload. In our instance, the data and the payload would actually look like this, right? So, whenever somebody buys or sells, we would see that response. So let's go back to KSQLDB. We've had a look at the stream, and this is kind of what you could see. This is just a different view of what we saw before. Now, we also need to create a K table. A table is, again, analogous to a database table, but inside of a Confluent table or a Kafka table, the last event that happened, so imagine this for a second, the user ID, which is the primary key, at 12:55 p.m. Registers, into an application, and then again at 12:57 p.m. they register into an application. What would happen in the table is it's the last event that happened that would get kept inside of the table. So let's actually go and have a look at KSQL. Let's have a look at the tables. In this instance, the table that we've just created is users. Have a quick query of the table. You've got to give it a second to run because, yep, there you go. And just worth pointing out, when you're actually running these exercises on your own, it takes a few seconds for the connectors to come up, for all the components to come up, which is kind of why I cheated and I pre-built this stuff yesterday, because I'm very conscious of the time. I think we might finish a little bit early, but that's okay. I'd rather finish early than late. But yeah, it takes time for these resources to be provisioned. So just be patient as you're building them and keep an eye on them. So in this instance, we're looking at the table. Effectively, as people register, it goes into the table. Now, I can see some of you asking the question, what's the difference between a table and a stream? I'm actually going to let you go and look that up because that's actually an interesting piece of information to try and gather on your own. It's quite interesting, the analogies between a traditional database table and a Confluent table and a Confluent stream and what you see in a database, right? One, it's effectively eventing 101. Quite interesting bit of research, if you like. It'll only take you 30 seconds to go and look up. Okay, so again, this is the data that you'll see. There's some instruction here about offset equals earliest. You won't have to do any of that. You can just run through this. It'll be fairly straightforward. Now, the next step of the exercise asks you to set up what's called a persistent query. Now, we've actually got a couple of persistent queries here. So a persistent query is effectively, if you think of a traditional database query, that's always running. So in database land, when we run a query, what happens is it's a static data set, right? It'll go and fetch a data set and bring it back. In Confluent, in Kafka land, what happens is the query is always running. So as events happen, it picks up new events. And why, I can hear you guys asking, well, thinking, why is that important? It's because events happen whether or not we're around, and we want to be able to process events as they happen. So in this instance, what we're doing is we're doing a select on events as they happen, and then we'll do something from that and process it. In this instance, what we're doing is we're actually enriching a data set. So as somebody purchases stock, what will happen is we'll join that to the users table. So we have the user who's actually purchasing stock as opposed to just the user ID, and we'll turn that into a stream. So in this event, we're creating a stream called enrich stocks. And if you look at this, this looks like a traditional database join, like a left join or a full outer join or whatever. The join conditions are very similar. In fact, exactly the same as a traditional database join. But what's happening is it's constantly applying that to an event stream so that as events happen, we're joining it to basically the events as they happen. So let's have a look at what that looks like inside of Confluent Cloud. Let me just verify, is stocks enriched. So as you can see here, what we're actually doing is user ID, region ID, gender, side. Let's have a look at what that is in a second. Quantity, symbol, price, and account. So basically, we're joining the users table to the stocks table and finding out who's buying what real time. So let's go KSQLDB. This is the stream that we've just created. Let's have a quick query of the stream. There we go. So in this instance, we're looking at someone's purchases from stock. Well, we're bringing back extra information. So in the stock purchase table, we don't know, what region they're in. We don't know what gender they are. We do have their user ID. There's a whole bunch of other stuff we don't know. So we're joining actually two streams to give us a better view of a user than we normally have when an application is just purchasing, or rather when a user is just purchasing something. So typically what would happen is we would just have the user ID and the stuff they're purchasing, but in here we have their gender, the region that they live in, and a whole bunch of other stuff. So the question is usually asked, why is this important? Like if you think about a traditional purchase use case, forget stock, think about retail. If I'm in a clickstream, I'm purchasing t-shirts, I'm a male, I live in Australia, I'm buying 5 t-shirts, I live in this region. And the application real time, or rather the thing that's monitoring all the purchases globally, is seeing people buying like 50, 60 t-shirts of one particular t-shirt. What will happen is, either machine learning or AI will pick up on the fact it says, what's making these people purchase right now? How do I get them to purchase more? What's this item? How is it popular? But at the same time, you're doing things like backfilling inventory. You've just sold 60 t-shirts, which you need to refill again, of particular sizes, etc. So this is one of those use cases where it's not just enrichment, but there's a downstream flow of this. So typically this goes to things like, data warehouse, analytics, machine learning, also like real-time sales and stuff. So, when you see banners, these are hot items, that sort of stuff within an application you're browsing. This is the mechanism that does this. Now, we'll go back to the API way of doing this as well. APIs traditionally push-pull. This is probably not a great use case for an API, but let's just say, one of your downstream customers wanted to know what was important or what was selling at any given time, and they could, co-sell or attach something to that sale. An API, query basically saying, hey, look, what's really hot at the moment? Here's a whole bunch of stuff that we can give you to attach to, advertising within somebody's clickstream. That's a pretty good example. I'll take a few seconds to see if there's questions. No questions. Okay, cool. I'll keep going. So yeah, effectively what you're seeing here is like an enriched stream of data. Let me go back to stream lineage, and this is quite unique to Confluent Cloud. What you're actually looking at here is the topics and the streams. And as you can see the data flowing into stocks enriched, and this is the join. This and this. Keep attention to the width of the lines. The width of the lines is reflective of the amount of data flowing to that query or that topic at any given time. So that's not a lot of data, whereas opposed to this and this going into stocks enriched, that's a fair bit of data. Okay, so we've actually gone through stocks enriched. We've gone through this topic. If you wanted to go through a topic and have a look at things like production and consumption. Production means the number of messages or data being produced. Consumption means the messages I consume, like in and out. These are the fields. We didn't set up a schema for this, but this is the topic configuration. The overview is a pretty good place to go and have a look. You can also see it in stream lineage. Like I said, this is the enriching and this is the joined. We do a couple of things here downstream. We'll go through that in a second, but effectively, this is a real-time data stream of people purchasing things. Now, you can also do things like aggregate data in KSQL. You go back. So in this instance, we've created a table basically that aggregates a whole bunch of data. In this instance, the number of times the stock has been bought. As you can see, very SQL-like, count quantities, total times bought from stock streams with, site equals buy. In this case, we're looking at, things that are being bought and not sold. Let's actually have a look at the table, see what that looks like. Let's query the table. So again, for you guys to set this up, you basically copy and paste this into the editor. And then what I've done is here is basically just do a select star from the query. Just give it a second, like I said. So as you can see, it's counting the number of times a stock has been bought. And this is just a table that you can query. Keep in mind, the value of this is that it's reflected real time. It's not like a batch job that's done at the end of the day. So as the event happens, the data is updated real time, and anybody who wants to query that either via an API or via produce and consume, they can do so. Now, before we go into the fraud detection stuff, I'm going to go into the last basically table. In this instance, total stock purchased. So let's go into tables. So as you can see, what's happening is it's aggregating the number of times a stock was purchased per stock price or ticker. So, Microsoft is MSFT, whatever this relates to. It's the number of times it was purchased, globally, as opposed to today, which was the last query that we did. I think it's probably not wise for us to sit here and wait for a third one to come up, but yeah, that's a pretty good example. Now, we're going to walk through a couple of series of what we call anomaly detection. I'll take you through the anomaly that we're trying to detect and how we set up basically the catch statement to identify either a fraudulent transaction or just something weird that a customer would be doing. In real life, the easiest analogy I can give you is, as a human, the number of times you can swipe your credit card in a minute, let's say 3 times, once every 20 seconds. You can set up a fraud detection window and says anything that's trying to, authenticate a credit card more than 10 times a minute, which is very hard for a human to do, would be a fraudulent transaction. We're doing kind of the similar sort of things here. What we're doing is we're looking at, purchases of stock that don't look quite right, and a whole bunch of other stuff. So we're actually going to create a table effectively that looks at a tumbling window of 5 minutes and aggregates purchases. So stocks purchased today, let's have a look at that. So within a tumbling 5 minute window, you're looking at, stocks that are being purchased. Now, you can see the quantities are all roughly the same, 78, 80, 90. Somebody goes and purchases a value of like 500, and you would have something consuming these messages. And the minute you see a value of like 500, 600, you would set off alarm bells, basically because it doesn't look like a regular transaction. If somebody's usually purchasing 80 or 90, the law of averages says if somebody's purchasing 500, they must know something, like the stock price is going to go up. And that's kind of the point of this query. It's to show you, what the average is and kind of make up your own mind around what, what a number that is too big would be. So in this instance as well, we've created accounts to monitor. Let me just see if we've got some questions before I go on, because I get the last bit's a little bit tough. Any questions so far? Okay, no questions. I'm happy to go on. So effectively, in this instance, we're creating a table, particular window start, particular window end. We're counting, as quantity. We're using the stocks enriched stream, which we created before. The window size is 5 minutes. So let's have a look at accounts to monitor. So let's have a look at this data. So you're looking at a particular window, like a particular user. This is their account. This is how many shares they're buying, presumably. Nothing too weird in here. Well, what you would do is, again, you would probably set up a consumer that says, all right, query the data, find me some data that looks really odd, and then basically identify, people doing the wrong thing. This is effectively what I've been talking about. Let me go to KSQL query. So we've actually set up a couple of streams, right, where people may or may not be doing anomalous things. In this instance, let's have a look at accounts that are actually purchasing more than 100 shares within that window. From memory, I did this. Yeah, there we go. I did this last night, and you can see people. I mean, 100 isn't that much, right? In terms of purchasing stock. So what we can actually do is, let's change that number to 500. Make it a little bit more aggressive. Yeah, from memory, there's not many people purchasing 500 at any given time. So let's try 4. Let's try 2. So these are people purchasing more than 200 stocks within that window, that 5 minute window, 207. Look, in real life, probably not a big deal. But again, like if we were doing fraud detection, let's say on a, on a real account, somebody's purchasing, 207 shares, wouldn't really set off an alarm bells. You might change that number to 500 to give you a better indication of when things looking weird. Again, the reason we use stocks is because it's the easiest way to get people to grasp, fraud detection and that sort of stuff. But again, we could be using things like credit cards and whatnot longer term. So let me stop this query. So finally, we're going to go and have a look at accounts rather than purchasing stocks. So what we've done is we've created a whole bunch of resources. Let me zoom in. We've created a whole bunch of resources and applications. So topics, meaning analogous to a database table, basically where you can store data. A stream of data, meaning data flowing in and out. A query, which is a continuous query, which sits there and watches data as it flows in and out and transforms it. Unlike traditional SQL, it's always running. In the final example, what we've actually done is we've created a table called accounts to monitor, where every account is going, and we know what they're purchasing within a 5-minute window. In this instance, we're actually going to run a query. We're trying to find. Tell you what, if this is the only mistake I've made today, that's not too bad. So what you're actually looking at here is me looking for a particular account, in this instance, ABC123, and seeing what they've purchased, over real time. So as they do purchases, I know what they're buying, I know what they're selling. You would effectively set this up for a filter, because here you know which user you're looking for. But you could change this, where symbol is of some value if you're watching a particular stock, where quantity, okay, so that looks dodgy, 2518. It's quite a lot. So yeah, there you go. That's an actual fraud detection use case where we've picked up 2 very weird transactions, a couple of thousands of stock being sold. The same user? It is the same user. So this person is shifting 5,000 plus of the same stock within a couple of minutes. Probably worth looking at. So again, it's like, because you're monitoring the stream real time, you're not waiting for analytics to push this out to you at the end of the day in an ETL or whatever. You see this as it happens. So, in real life, this would go to a consumer, to some sort of alarm or dashboard, and say, hey, look, we know this person's just sold, over $5,000 or $6,000, sorry, 6,000 units worth of stock. Probably worth looking at. Keep in mind, this was a real-time thing created by the data generation character, so it's quite a good example actually. Now, before I wrap up, I'm going to remind you, when you actually run this workshop, what you need to do is go and delete these resources at the end of your exercise. If you leave this running for a week, it's going to sting you. Make sure you go and delete the KSQLDB instance and the cluster. If you need more credits, you can always reach out to us, your account executive. They can give you some free training credits. There's also a whole bunch of KSQLDB tutorials which you can go and look at. I strongly recommend that you go and look at streams and tables in Apache Kafka. I know the article is old, but this is a fantastic, fantastic representation of what the difference between a table and a record history is. So, like, you would have heard me say state of the board, as in a current snapshot of what's going on, whereas a sequence of the moves is the entire record history. So, within a stream, we see everything. A table is a point-in-time snapshot. That's the most diluted version I can give you, but it is so much more powerful than that. I'd strongly recommend you go and read this article. 20 minutes of your time, it's worth a lot more than that. We'll make sure we get this resources to you, so you can follow and go and do this at your own pace. If there's any questions, happy to take them now. I am going to stop sharing my screen.